Okay, welcome everyone. If you're watching this video, you've been selected to create a headphone rack for the woodshop using the CNC router, a couple CAD programs, and your brain power. So what you see currently up on the screen is just a simple set of headphones that you'd see in a computer lab with a mic. What you're going to be doing is something similar, however, headphones are going to be acting as ear protection, which will protect students' ears in the woodshop. Same concept, we have a box of them. They need to be assembled and put up on a wall so that students can easily see them, put them away properly, and it will foster safe ear protection use within the lab rather than have them stuck in a box. So at this point, you can kind of see how we have a headphone. I'm thinking something similar with like a 1-inch dowel where the headphones will hang off of, and we have a board that we're going to be drilling holes through using the CNC router. We're going to be milling them using an end mill, and then we're going to be placing the dowels into the pockets, and it's going to create a two-dimensional matrix, and you should be able to bolt it to the wall and so forth. So here's a couple images to kind of walk you through my idea. Something along the lines of a little bit neater than this, where we're not going to use pegboard, we're going to use dowels that are pre-drilled, and dowels are going to fit into the pockets, and then the entire board will be put up against the wall. So as you can kind of see, here's another example. These are audio headphones. We're using this idea for our ear protection. So let's get this started. What you're going to need to do is measure how wide each headphone is. They're basically the same model, so how wide is it from ear to ear? Add additional measurements or distance for spacing above and below, and then figure out how many we have and how that can fit into a two-dimensional array, X and Y. So if we had, 64, which we don't, we would have 8 headphones across, 8 headphones down, 8 times 8, 64, and so forth. I'm thinking we have a set of 24. So how would we design that? First, you need to imagine how big our base is. So you're going to have to do some calculations to figure out, with some sketching, how many headphones we need to go horizontal, how many headphones we need to go vertical, what's the padding or the buffer space between them, and so forth. So once you've figured that out, which I'm not going to do for you, you're going to go to Illustrator, Adobe Illustrator, which you probably can't see because it's putting the credit over on the other screen. What you're going to do is just simply search, hit start, type in Illustrator, it'll show up. Okay, once Illustrator started, you're going to hit File New. The dialog box should appear that asks you how big your document should be, and so forth. So at this point, this is where you will have already premeditated the size that you need. This is going to reflect the size of the board that you're going to be cutting using the CNC router. So when you can see your 8.5 by 11, which is your standard piece of paper, you're going to change this to something much larger. Excuse me. Something like 48 inches by 36, or 36 by 48, or 24 by 48. This is your design, and you need to obviously check it with me before you spend all the time programming the CNC router to cut these parts. You wouldn't want to have to do this twice. Once you say OK, you'll see this rectangle that represents the board that you wish you had on the wall that would hold our headphones. Then, with the rulers, you're going to hold Control, press R. Your rulers will pop up. If you right-click in this corner, you can switch it from whatever unit you wish. Obviously, inches should make the most sense to you. And then when you click and drag from the ruler space out, you can place a guideline. So if I click it and it turns blue, as you can see here, I can change its X position. As you can see, it's 5.8 inches out. If I put in 10, press tab on the keyboard, you can see that it's exactly at 10 inches. So maybe the headphones take up 10 inches of space, and you're going to bring these out in multiples of 10. So the next thing would be 20, followed by 30. Once again, I'm using imaginary numbers. And let's do one more. Let's do 40. Okay, so if we have 10 inches apart, obviously it's not evenly spaced, as I'm not doing the math for you. These are going to be basically, let's say, horizontal positions of where the center points are going to be. Now we need to do vertical. So maybe we need to go down 10 inches as well. So we're going to go to our y-axis, 10, drag out another one, 20, and we'll do another one, 30. So now that we have our 30, once again, my matrix is poorly done. We have intersections of which you can draw on. And if you're not getting these little green guides that pop up that give you words, you're going to go to, I believe, View, and you're going to make sure Smart Guides is checked. If Smart Guides isn't checked, you're not going to get these little prompts that tell you intersection and so forth. Then you're going to hold down your mouse over the rectangle tool and select Ellipse tool. At the top, you're going to select a color in the stroke area. Choose black, 1 point. We don't want these circles to be filled with color, so we'll leave this with the red slash, kind of like a no smoking sign. That's no color. And at intersection, you're going to click and drag. And if you notice, it's not coming from the center, but if I press Alt, it will. So I'm holding Alt on the keyboard right now. Now if I hold Shift, my ellipse will go to a perfect circle. So what we want is a perfect circle at the size that we actually want to drill it. So if you notice, I'm at 8.2, 8.2, 2.1. I'm going to go down, I'm going to try to get to 1 inch. I might not be able to. So let's just leave it like this. And this is where we're going to play with the circle itself with sizes. So if you look here, our width and our height are 1.4952 on both. This is a circle. So if we were trying to use dowels that were exactly 1 inch on the outside diameter, and we want these to be pretty snug, we might want to do a couple practice holes, but traditionally, if you want them to be snug and not come apart, we'll use a little bit of wood glue. We can actually do like 1 inch and maybe 5 thousandths, 1 inch, 10 thousandths. But we really don't want them to be exact because sometimes they might not be able to be pounded in. So we'll just type in 1.005 for 1 inch and 5 thousandths, or let's do 1 inch and 10 thousandths. This is where you're going to have to do some research. I'm going to switch this to 1.010. If they're both equal, which they are, we have them. We have it set to a circle. Now I'm going to zoom in by pressing Control plus. You can see my circle here. You can scroll with the handles. Now if I want a couple this direction and a couple this direction, I might be able to do a pattern of specified steps. However, if you don't know that, I'm not going to go into detail about this. I'm just going to copy and paste and place on center. Okay? You have to be very careful when you do this. I'm going to hit Control C, Control V, grab from the center point, and whoops. Should be able to grab from the center. And then snap right to the intersection. And then repeat this over and over and over again. Okay? So I'm going to hit Control C. Actually, I'm going to hold Shift and get both of them. Hit Control C. Now hit Control V. And now I can do two at once. Grab the center. Center to center point. Or intersection. And the smart guides will also assist you. And now we're perfectly lined up with 4. I'm going to hit Control minus to zoom out. And as you can see, I'm going to hold Shift when I get the first one. Second one, I accidentally grabbed the guideline. I don't want that. I'm going to deselect by just single clicking. Hold Shift, click, 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 click. Control C, Control V. Grab the center of one of them and snap it. Control V, grab the center and snap it. Okay? At that point, we're kind of ready to save this, import it into another program, and then have the router cut it out. So I'm going to Windows select my guides and press delete. Windows select my guides and press delete. I do want a square around my border, or a rectangle around my border of my shape. Go to rectangle, black, One stroke is natural. Intersect, 2 intersect. This is going to give you the exact shape that you want. And as you can see, it's 48 by 36. Save this. Put this in a location that you can retrieve it from. I'm choosing my desktop as an example. Pegboard example. Yours will not be called pegboard example. It will be called like pegboard version 1, version 2, version 3. Keep track of your files. I'm going to hit enter. Say OK. I think I can leave it the way it is at Illustrator 5. We'll find out. Hit save and wait. I'm going to leave this open, but at this point you probably don't need it anymore. So we're going to minimize, and we're going to find VCarve. V as in Victor, carve. So if you type VCarve, you should be able to see it. Pulling it up. You're going to create a new file. It's going to ask you the same questions Illustrator did. Ours was 48 by 36, so we're going to do 36. Since this is cutting material, it's going to ask you how thick it is. This is a 3-dimensional program, so the third dimension is how thick. We did how wide, we did how deep, now we're going to do how thick. Okay? You're going to pre-select the thickness of the material that you're going to cut, and that's what you would normally put in here. So let's just hypothetically say that we have 3/4 inch material. 0.75. Okay, our origin is going to be at the bottom left corner, just like SolidWorks uses, and we're going to say OK. At this point, we're going to import artwork, and that should be up here. Copy, paste, import. Import vectors from a file. So we want to import vectors, which is what Illustrator creates. You're going to click this. You're going to go to your location that you saved your item in, and you're going to find it. I'm going to type in peg, and as I can see, it's there. Click OK. Open. As you can see, I have circles and a rectangle highlighted in pink. If I click off of it, it all goes to black. So if this was set up the way that it needed with actual measurements, we would cut this part. How would we cut it? Well, this section of the video is going to detail that. If you're not ready, there's no point in watching. We're about 12 minutes into the video, and if you're only trying to understand how to create the artwork, you want to stop playing the video at this point and make the artwork with the actual measurements that you've created through your calculations. Okay, so now carrying on, we're going to assume that you have the correct geometry, we have a correct file in, and we want to route these. So a router can cut inside this circle, or it can put its tool on the outside of this circle. We want, obviously, this stuff in the middle to go away down to a certain depth, so we want to choose the inside of the circle. Okay, so you're going to see some options here. Now, let's just think about the inverse. We have a rectangle that is on the outside of our shape. So we do not want to create a toolpath where the tool is on the inside of this line, because our measurements will be off. It won't be 36 by 48 when we're done. So we're going to move the tool to the outside. We'll get these nice sharp corners, and we'll get the exact measurement that we want pre-cut for us without having to lift a finger. So at this point, we understand that we need to do the outside of the rectangle, and we need to do the inside of the circle. Based on order of operation, you want to do what's logical. We're going to drill the holes first, or what we call pockets, and then afterwards we will cut out the shape. If we cut out the shape first, sometimes the size can be reduced, and surface area wise would have been reduced. Holding strength will have been reduced, and then your part might shift while it's doing the second operation. So you do what does the least amount of modification to your part first, if you can, then you cut out the shape when you're done. That way it ensures that it's maximum strength for holding. So how do we do that? Well, our artwork is done, so all of these tools are for drawing things that needs to be cut out. We did this in Illustrator, so all we have to do now is go to Toolpaths, and we're going to set it up. So over here we have Pocket Toolpath and Profile. So we are going to pocket the holes, and we're going to profile the rectangle. So we're going to click on Pocket. When you do so, it's going to start at 0, which is the top of our material, and it's going to go down how much. So if we're using 0.75 for a thickness, a 1/2 inch would probably be adequate. There's enough material to be held down. These pegs aren't going to be climbed on. They're going to be holding light headphones. So in terms of the purpose for what we're doing, this should be a suitable depth. So let's do 0.5. We're going to press tab on the keyboard above caps lock on your keyboard. And now the next question is, what tool are you going to use? This is a 16th inch end mill, and that's extremely inappropriate for what we're going to be doing. We're going to be choosing a 1/4 inch. We could even probably choose a 1/2 inch, but we don't really have a good 1/2 inch bit. So we're going to stick to 1/4. So we're going to hit select, so we can select a tool, and we have our end mills. Now a 1/4 inch end mill is default, and it's already in your library, so you're going to select it. Please don't mess with any of these options because it's already pre-programmed to do a few things. One thing we are going to change is our revolutions per minute, which is the spindle speed of which it turns the tool to cut the part. Excuse me. So we're going to go up to 9,500. Okay, and then in terms of feed, how many inches per minute will go in? I like to use 11,110 for routing as a default base. We're going a little slower than that, so it's not going to be as loud. And then in terms of feed rate, I'm going to bump that up to 60 inches per minute. We'll leave the plunge rate the way it is, and it's just going to go down at that inches per minute. This is going to go horizontal or vertical on the X and Y, and then this is going to spin the cutter tool to remove material. This is the overlap to make sure. Typically we're going to cut the radius of the tool, as the tool's 0.25 in diameter. Here's your radius for overlap, and you want to say apply so the settings stay, and you're going to say OK. You'll see end mill here. So the next question is, what geometry do you want? So we're going to select, let's just take a look here. We also want to be on the inside of the line, and we will find that option that I can't see off the top of my head at the moment in a moment. So we're going to select this. If you see, you click the other one, that disappears. So we're going to hold shift and get all of these holes. Now I'm going to shift and click a window, and that's even faster. So shift, click a window if you need to select more than one item in a range. So we have those, but not the rectangle. So now we're going to go to Toolpath. And since this is a pocket, it actually knows to stay inside that line. Okay, it's basically when we do a profile, we'll have to make that decision. So we're going to leave these all as such. You can see it's going to take 4 passes for each hole. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and so on. Okay, you're going to hit calculate, and you can see the blue, which represents the travel. I'm sorry, the cutting, and the red represents the travel. So if we're on 3D, should be able to click and drag this to be semi-isometric. You can zoom in. It's going to start at the corner, and it's going to start its first operation. Green is plunging down in, blue is X and Y combination, and then red is above what they call the feed plane, which will allow it to travel without breaking. So now we can play this. Should be able to play this operation here. Hit play, and you can see the hole is cut. I have my resolution turned down for speed. I don't need fancy graphics to understand that my holes are where they need to be. If you want to pan like I'm doing, you're going to smush your wheel mouse in and then drag. Okay. If you want to 3-dimensionally rotate, you're going to click left click and drag. Okay. So at this point, I'm going to just go over to my new. I'm going to zoom out. I do not understand why that actually has moved, unless when I clicked and dragged, I did something. So I'm going to go to undo nudge. Yep, it looked like I definitely moved it for some reason. I'm going to hold down Control Z. Here it goes. Okay, then it disappeared. So let's redo import file. Not sure where the nudging is coming. I'm going to undo my nudge. Let me go over to my toolpaths, and if I click on Pocket, the programming is there. So somehow I bumped the artwork. So use that as a tale of caution. All right, so the holes are there where they need to be, hypothetically. Now we're going to do the contour. So over here, you're just going to hit close because Toolpath 1 is done. Okay, we're done previewing it. So we have one pocket. We're going to use the same tool to do the next operation. We're going to select the outside rectangle, as you can see, and we're going to grab contour or profile. When you choose profile, we're going to be on the outside, as I told you, not on the inside. Or we don't want that. We want the outside. How deep? Well, this would be how thick the material would be. So if it was 0.75 thick, 0.76 or 0.765 would cut through the material entirely and into the table that holds down the material, which is called a spoil board, and you spoil it over time. It's a good way to remember it. So we're outside. We're going down deeper than the part is thick, so it will release from the entire larger than what we need material plane. And we have our depth. It's going to take 7 passes to do it. We're on the outside. We already have it selected. So you're going to hit calculate. And now it's warning us that we're going to cut through, which is what we want. If we had a special surface down, we'd hurt our router. We're going to say OK. And as you can see here, our toolpath operation, pocket 1 and 2, if I press play, okay, it cuts it out. If the material was larger than what I wanted, you would actually see a cut on the outside. Okay, so now what we're going to do is just go back to new. Our program is done. You're going to have both of these checked, pocket. Well, first let's hit close. We're going to hit pocket and profile. You can see the direction of which it'll cut. And now the final thing is, obviously, save your work. Make sure you save this, because if the bell were to ring, you obviously wouldn't have this work saved for you unless you gave it a file. I'm going to pretend I already saved, and now I need to export my file, which is called Saving Toolpath. The question is, what are we going to save? Both of these in one program? You should only see one thing here, and if you don't, you need to see me, and we're going to fix your computer so that the post processor is proper for the machine we're actually posting to. These instructions are being written for the velocity control, which is the computer that drives the CNC. There's thousands of different ones, and this is our specific, and I have a special file for you to use. So if your computer is not configured with it, most likely it's not, you're going to have to find me. I'm going to have to give you the post file and show you how to install it, and then you'll be able to output your program. If it's not there at this point, you can save your file by selecting File Save As, and then open this back up once we fix the post processor right here. Okay? So if it's there and it says velocity, you're just going to save toolpaths, and you're going to call this like peg board project, something like that. No spaces, no uppercase, keep it simple. Hit save. It's going to be an NCC file, numerical control code. Okay? That file is going to be put into the CNC router, and then I'll show you how to run the router personally. Okay, so if you've gotten this far down and you've succeeded in everything I've shown you, fantastic job. Otherwise, rewatch the video in detail. I've annotated literally everything that you need to know. Okay, guys, good luck.